In this next section, we're going to be taking a look at how to build the equations of planes in space. And first, let's motivate the idea of how we're going to formulate this equation. So, let's say that we know a point in the plane, any point that we want. Let's call it x naught, y naught, z naught. And let's say for some reason there's a normal vector to the plane. All right? And I don't know if we've used the term normal before, but normal basically means forming a 90-degree angle. All right, so we have a vector and a plane that form a 90-degree angle. That's what normal means. And that vector n has the values a, b, c. Notice that these are not direction numbers because it's normal to the plane. And then we have the plane that consists of all the points. Let's just call them x, y, z. So in other words, what we can do is we can create a vector, pq, and pq is going to be orthogonal to n, because any vector that's in the plane is going to be orthogonal to n. So we get that pq dot n is going to be equal to 0, because indeed we know the definition of dot product equals 0 means orthogonal. And so what we can do is we can just take pq and dot it with n, or in this case I actually took n and dotted it with pq. Now q is the difference, terminal minus initial. So x, y, and z are any points, so that's how we get x minus x naught, y minus y naught, z minus z naught. And when we dot those together, we get this equation of a plane. All right, so that's going to be our general form or standard form of an equation in a plane. If we distribute a, b, c, and then solve for getting all the variables on one side and the constant to the other side, that's our general form. All right, so two things that we need at minimum. We need a normal vector to the plane, and then we need a point on the plane. If we have those two things, then we can formulate the equation of a plane very easily. All right, so let's take a look at three examples of being able to formulate equations of planes in 3 dimensions. So we have a point on the plane, 0 to -1, and we have a normal vector. It just gives it to us right away. All right, so in this problem, x naught is 0, y naught is 2, z naught is -1, a is 3, as it's the coefficient of I, b is -2, and c is -1. And we're literally just going to throw that into the equation that we have above. Okay, so we're going to throw it into this equation, and then more useful is probably the general form. All right, so we're going to use the standard form, get to the general form. So we're going to wind up with 3x minus 0 plus 2, or -2, excuse me, y minus 2 plus -1 times z minus a -1, and that's equal to 0. And we can clean this up. 3x minus 2y plus 4 minus z minus 1 is equal to 0. Or another way to write that, or a couple ways to write that, 3x minus 2y minus z plus 3 equals 0. Probably the most useful way to be able to define this plane, 3x minus 2y minus z equals -3. And in general, that's the most useful way, because now we can find intercepts of the plane, which could be a little bit more useful later when we look at some more problems such as distances between points and planes, etc. A second example. The plane that goes through the point 2, 4, 5, perpendicular to the line. All right, so that's a good thing, because if it wasn't perpendicular, this problem would be a little bit more difficult. In fact, a lot more difficult. So we already know x1, y1, z1. So x1, y1, z1. And then we know that a, in this case, is going to be the coefficient of t, which is 1. B is the coefficient of t in y, which is 2. And c is the coefficient in front of t, which is going to be 4. All right. Again, that's okay because it's perpendicular to the line. Again, if it wasn't perpendicular, we'd be in a little bit more difficult scenario. We're going to first of all use the general form. and then we're going to get to our standard form. So we're going to have a, which is 1, x minus 2, plus b, which is 3, y minus 4, plus c, which is 4, z minus 5, which is equal to 0, or x minus 2, 3y minus 12, 4z minus 20 is equal to 0, or x plus 3y plus 4z minus 34 equals 0. And then if we were to add that 34 to both sides, x plus 3y plus 4z equals 34. And that's probably going to be the most useful of the different forms that we can generate. One final example. Now this one's a little bit tougher because although we're given several points, we're not necessarily given the normal vector to the plane. All right, so we're going to have to do a little bit of work to be able to get to the equation of this plane, unlike the other two where it was pretty much given to us fairly easily. So one thing that we can do is we can label these points. Let's call them P, Q, and R. Now all of the points are in the plane, so all we need is a normal vector. We could pick any one of those 3 points, and that could serve as our x naught, y naught, z naught. To be able to get a normal vector, well, what we might be able to do is to employ something that we learned in a previous lesson. All right, so let's get some vectors. So let's get vector PQ, and let's get vector PR. All right, and again, terminal minus initial. So 2 minus 1 is 1, 0 minus 1 is -1, 2 minus a minus 1 is 3. For PR, 0 minus 1 is -1, -2 minus 1 is -3, 1 minus a -1 is 2. Right, so those are our vectors. Both of these vectors are in the plane. All right, so that doesn't necessarily give us the answer yet. However, what we could do is we could go through and try to find a vector that's normal or orthogonal to both of those vectors. And remember, that's our cross product. Okay, so what we could do is we could find PQ cross PR, and that's going to be orthogonal to both vectors, but then it's also going to be normal to the plane. And that's going to give us our N, which is going to give us our A, B, and C. All right, so N is going to be equal to PQ cross PR. And remember from our last video that we just use I, J, K. We're going to use the 2 vectors that we just found, which are 1, -1, 3, -1, -3, 2. We're going to throw them into a determinant, and now we're just going to compute the normal vector. All right, so remember, cover up I, you're going to do a cross product. And again, since we've done this several times, we're just going to go through this rather quickly. So we get -2 plus 9, which is 7i. Remember, the second term is negative, or the second term you subtract. That's going to be 2 minus a minus 3. So that's going to turn into a positive 5, but we subtract, which is a -5j. And then for k, we get 2 minus a minus 3, which ends up being plus 5k. All right, let me double check that really quickly just to make sure. So that's going to be 7, and it was just odd that we got 5 for both of those, so I'm just making sure I didn't make an error. So that's going to be 2 minus 3 is good, and then for k, okay, so that is not 5. Let's try that again. So that's going to be -3 minus 1, which is going to be -4. All right, good thing I checked that. So now we have our A, B, and C. All right, so A is 7, B is -5, C is -4. And now we can formulate the equation of our line. We could use any of the points, and we should still be able to get to the same answer. I'm just going to use Q because it has a 0 and no negative numbers. So Q is 202. So our plane is going to be 7x minus 2 plus negative 5y minus 0 plus negative 4z minus 2 equals 0. 7x minus 14 minus 5y minus 4z plus 8 is equal to 0. Or in other words, 7x minus 5y minus 4z is going to be equal to 6. And that should be the equation of our plane that passes through those 3 points. Of course, as a check, what we could do is just substitute any one of the points back in, and it should satisfy the equation. And if it doesn't, that means we messed up somewhere. All right, so let's just plug in p, 1, 1, negative 1, and see if that works. So it would be 7 minus 5 plus 4, and that's equal to 6, because we'd end up with 11 minus 5, and that's a good thing, because if it wasn't, it wouldn't satisfy the plane. All right, so there's always ways to check these answers. As we did before, we could go up here to the previous example, and remember we had the point 2, 4, 5, so we could plug that in. So we get 2 plus 12 plus 20 is equal to 34, just by subbing 2, 4, and 5 back in for z. All right, so I do urge you to make sure that once you get your answers, to check the answers, just to make sure they do make sense, especially with ones that are easy like this, such as planes. So in the next video series, we're going to take a look at angles between planes and then distances between planes.